This is not working well. Okay, smallest unit of matter is the atom. If I have an atom of carbon and put a whole bunch of carbon atoms together, it makes a what? It makes elements, okay? The elements of the periodic table. I can't make a diamond without putting a whole bunch of carbon atoms together, but that's the element carbon. So all those atoms together make up the diamond, or gold, or aluminum, or iron, any of those elements on the periodic table. So the difference between them is an atom is just one single little unit of matter of that particular element, and a bunch of the same atoms together make up elements. All right, number 2. The nucleus has all the mass of an atom and contains what and what? What's located in the nucleus? Protons and neutrons, right. Okay, so they are our heavy-duty guys that make up the mass of the nucleus. All right, what are the 3 particles? Well, we already said inside the nucleus is the protons and neutrons. What's hanging out outside the nucleus? The electrons. The charge of a proton is positive. P for positive, proton. Neutrons are 0 or neutral, and electrons are negative. Correct. All right. Number 5, the atomic number. That's that smaller number. So if we're talking about carbon, and carbon looks like this on the periodic table, the smaller number is the atomic number, and it represents the number of what's that never ever changes. Protons, good. Okay, the mass number is the number of what and what. What makes up the nucleus? Protons and neutrons, so that's the larger number, the mass number. Okay, the atomic mass, the larger number, is the weighted average of all the elements what? Anybody remember?
12.011.
Isotopes, right. So when carbon has carbon 12, carbon 13, and carbon 14, we average all these together to make up the atomic mass, and in carbon's case it's 12.011. That's just all these 13s and 14s that make up the 0.00011 of the mass. Okay? So isotopes averaged together make up this atomic mass, which represents your protons and neutrons, because electrons are insignificant in this case of mass. An isotope has a change in number of, neutrons. What always stays the same? Protons. So protons are positive, but another way to think of it is protons are permanent.
Remember, protons, the atomic number, that's the number names. If you change that, it's a different element. So protons stay the same. If you change neutrons, that's an isotope. Isotope, Jimmy, neutron.
Neutrons change. All right, and just as a reminder, isotope, Jimmy, neutron doesn't blow up our lab. Isotopes and neutrons go hand in hand because the neutrons will change in an atom. 2 or more elements that are combined chemically are called a compound. And I said, remember, combined chemically. Anything combining chemically makes a compound, CCC. Okay? So if I take hydrogens and I combine them with oxygens and I put them together, what have I got? Water. Okay? An ion is an atom. Remember that. Ions are atoms that have gained or lost what? Electrons. So if I'm an atom of, let's say, hydrogen, and I give up my electron to oxygen, what charge do I now have? Positive, because I gave up my negativity to her. Now she's very negative and she's negative. Okay? Not always. Okay. If she has extra electrons and she gives it to me, she now becomes positive and I become negative. Remember that. Ions are atoms.
Protons don't change. Change neutrons, that's isotope. Change electrons, that's ion.
Going along with the change of electrons in an ion, an atom that becomes an ion, if you put 2 ions together, the electrons are gained or lost again. So if I'm sodium and she's chloride, I'm giving up an electron to chloride. We're bonding to become salt. That's an ionic bond. If there's a giving up of electrons to the other atom.
One becomes plus, one becomes minus, and opposites attract. That's a bond. That's an ionic bond.
Remember, I for ionic, I give, I'll take, but I don't share. Covalent bonds, electrons are shared. Think of co-captains of a team. They're sharing the job of being captain. So the covalent bonds are when the atoms are sharing their electrons in order to create the bond.
No means together or share together.
Okay, 13. The bonds between water molecules are called what kind of bonds? Hydrogen. Oops, I messed you up.
Yeah. Thank you.
Okay, so
There you go.
here's water. Okay, H2O. Think of it this way. The chemical formula for water is H2O. What does it start with? Hydrogen. Hydrogen bonds. Water's H2O, hydrogen bonds. Now, the next question, cohesion is polarity is when electrons are shared what? Unequally. So over here,
Sorry.
it's okay.
Yep.
Sister oxygen is supposed to share her electron cookies with her brother's hydrogens, her twin brother's hydrogens. She doesn't do a good job with that. She keeps some of those electron cookies to herself. So it pulls the electrons more towards oxygen and away from hydrogen, so they become a positive charge and oxygen becomes a negative charge. Therefore, we get a polar molecule. Because
Has
they're
poles. Positive pole and a negative pole.
right? Water's polar because they're sharing unequally. All right, next one. Cohesion is a property of water in which water molecules stick to what kind of molecules?
Water sticks,
Water with water.
co together to itself.
Co-captains, they're the same thing. They're doing the same job. Water with water. Adhesion is much like this sticky paper. Pretend this is water sticking to the window when it rains. Adhesion is water sticking to other things. A mixture, such as mixed nuts, are two or more molecules combined how? Physically, exactly.
Now we talked about two kinds of mixtures, right?
Number 18, if I want to make salt water, what is getting dissolved into the water? Salt, so it's called the solute. I am taking salt and shaking it into water, so you dissolve the salt into the water, solute. 19, so what's doing the dissolving in my saltwater solution? The water. It's called a solvent.
Water is the universal solvent. It dissolves things really well because it's polar.
So, let's do this. Solute is like sodium chloride, salt. Solvent is like water. If you put those two together, you got salt water. Okay, if I add solute with solvent,
What do you get?
what? Ooh,
Whoa.
wow.
That's cool. Cut again. Start to move over.
Okay.
Okay.
What do I get when I add a solute with a solvent? I get a solution.
That's one kind of mixture.
21. A blank is when two things are mixed, but no dissolving takes place. Think of Italian dressing. Suspension, right. I love Italian dressing, but I got to put it on quick after I mix it up because it's going to separate out if I don't put it on my salad quickly enough. All right, 22 through 26
Oh, wait a
is...
minute. Could you put the 20 and 21 of the two types of mixtures?
Oh, yeah.
I get your pen.
Okay, so out here, out for 20 and 21, solution and suspension from your worksheet that you did, these are both types
So that one question is what I was going for.
mixtures. Okay? Both types of mixtures. One has dissolving involved in it, the other one is just a suspended, the molecules get suspended, but then they separate back out. And next to suspension, you could write Italian dressing.
Example.
Any questions so far?
Okay, now your Socratic questions.
Okay. We're talking about pH. I wanted to see how much you guys reviewed your pH notes before coming in today. pH is a measure of how many whats are in solution. Hydrogen ions, right. That's really important. Acids have a high concentration of what? Hydrogen, and a low concentration of OHs, or hydroxide ions. So if you want to look at that in a teeter-totter type thing, acids would look like this. We have high hydrogens and low hydroxides. That would be your acid. All right, bases have a high concentration of what? The opposite. Hydroxides, and a low concentration of hydrogen ions. Okay, so this would be your base. Your OH is up and your H is down. That's your base. So you need to know that pH is a measure of the hydrogen ion concentration in solution. Buffer is a weak, a weak acid or base that reacts with a what? Acid or base? Okay.
How are people doing?
Pretty good. 71% the last two, and this was 86%. That's not bad. And buffers are important for doing what? Yes, 93%. You're starting to get this. Okay, so we have a buffer. I ate too much for Thanksgiving dinner. My stomach's pumping out lots of acid, lots of hydrogen ions. I take a Tums and it tweaks it back into place so that my stomach doesn't feel so bad. Make sense? All right, let's do this together, the pH scale below. Let me, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, here's my pH scale. When I'm down below 7, what is it called? Acids. When I'm above 7, it's bases. Okay? Where's my weak acid area?
7 to
Close to 7. So there's weak. Where's my weak base?
7 to 9.
Let's say 10.
7's neutral, so higher than 7.
Yeah.
To about 10.
It's like, yeah, 7.1 to 10. All right, where's my strong acid? Way down here. And strong bases.
So hydrochloric acid, what is it?
If it's 1.0, what is it?
Strong and acid. What's orange juice at about 3?
Strong.
Strong and
Yep.
acid, not quite as strong. What's coffee at about 5?
Weak.
Weak,
Yep.
but acid. What's seawater?
Weak.
Weak what?
But
Base.
Yep.
base, and bleach is
Strong base. Okay.
That's a strong base.
Any questions on anything on this side of the blue sheet? Because that's what you need to know for your quiz today.